Hello, I'm Mr. Bennett, and I'm back to teach you how to add signed numbers. Now, you've already been introduced to the integers, which are the whole numbers plus their opposites. Now we're going to look at how we can add signed numbers together. We're going to use a little layout and use some tiles that help to represent positive and negative numbers. So here's our layout. You'll notice at the top it says 0 because we've got nothing here. I'm going to add in one tile. This plus means positive 1. If I add a second positive tile, we get plus 2. Now I'm going to clear those off. Here's a negative tile. Notice when I put 1 down, it becomes negative 1. If I add 2 more, it makes negative 3. So let's clear those off. Now suppose I was trying to add 4 plus negative 2. So we'll do 1, 2, 3, 4 plus negative 2. Now when I combine these tiles, what you will notice is that when you combine a positive and negative tile, they disappear. And notice that we get a result of positive 4 plus negative 2 is positive 2. Let's look at another example. Suppose we had 3 plus negative 5. Now again, we're going to combine all of the positive and negative tiles that we can. And we see we get negative 2 left over. So whenever we combine positives and negatives in the same addition problem, it actually acts more like a subtraction problem, because some of those negative tiles will take away some of those positive tiles, or vice versa. Now let's see what happens if we have two negative numbers. Suppose we had negative 2, and to that we wanted to add 3 more. Negative 2 plus negative 3. Well, there's our negative 2, and if I put 3 more down, notice that I get negative 5. So a negative plus a negative gives us negative. We get an even more negative number. The same thing that happens if I had put down positive tiles. So now, we notice that whenever I add two numbers with the same sign, we actually combine their values. They get larger. 2 plus 5 would be 7. Negative 2 plus negative 5 would combine those two values, and I would get negative 7. But when we have numbers with opposite signs, then we get a subtraction. We subtract their two values. Which one is going to be positive? Well, let's look back again at the examples that we had. Let's say we have 2 plus negative 4. Is the answer going to be positive or negative? Well, since we have more negative tiles than we had positive tiles, when we cancel them out, we'll have negative tiles left over. So whichever number had the larger absolute value tells us what sign the answer is going to have. The same would hold true if I had more positives than negative. If I had positive 5 and I wanted to add negative 3, because I have more positive tiles than I had negative tiles, because 5 has a larger absolute value than negative 3, when I combine them, I have 2 positive tiles left over. So that's a positive 2. So how can we summarize this? Well, we can summarize it with the following rules. When adding integers with like signs, you keep the sum of the absolute values of the integers, and then keep the common sign of the two integers as the sign of the sum. I usually tell students that you can keep the larger one, because if they're the same, then obviously the larger one will be the appropriate sign. When adding integers with unlike signs, you first find their absolute values, subtract the smaller absolute value from the larger absolute value, and then keep the sign of the integer that had the larger absolute value. If we do that in both cases, we'll get the correct sign on the answer. Another way to look at this is on the number line. Take, for example, the sum -3 plus 4. Well, if we start at and go negative to -3, we're here. And if we add 4, we go back to the right 4, and so we're at 1. Similarly, what about -2 plus -2? Well, if we first go to -2, and then we go 2 more to the left, then we get out to -4. What about -3 plus +3? Well, here we go to the -3, but then we turn right around and go back to 0. This gives us an interesting property. When you add a number and its opposite, you always get 0. This is why our tiles canceled out in the previous examples.